As the sun rises over the vast expanse of Russia, its landscapes are endless. From Siberia's cold wilderness to Moscow's busy streets, Russia's size is daunting. But is it as vast as it appears on maps? Welcome to Map Projections, where Earth is flattened onto a 2D surface, distorting our spatial perception. In this guide, we challenge our world understanding, exposing the geometric trick that magnifies Russia's map size. Prepare for a journey that will revolutionize your worldview. Welcome to Knowledge Planet. Hello everyone, hope you're having a great day. Welcome to Knowledge Planet. Today we're exploring maps and geometry. We'll focus on the real size of Russia, a topic that has sparked intrigue. Is it as vast as it appears on the map, or is it a result of geometric manipulation? Prepare for an intriguing journey through map projections and geometry. Remember to subscribe, share this video, and give us a like or dislike. Don't forget to turn on notifications so you never miss a new video from Knowledge Planet. Let's get started. Have you ever pondered why Russia, portrayed on numerous maps, appears as a colossal expanse spanning a vast segment of the globe? This isn't an intricate conspiracy or illusion, it's due to geometry. The maps we commonly use, called Mercator maps, are accurate in displaying the shape of territories. However, they distort the size and area of land as we approach the poles. This distortion arises from the challenge of turning a three-dimensional object into a two-dimensional image. When representing a sphere, like Earth, onto a flat surface, like a map, distortion is unavoidable. This conversion is geometrically impractical. It's simply impossible to accurately reflect the size and area of land masses like Russia on Mercator maps without distortion. It's geometrically impossible. So let's delve into this concept a bit further. Visualize a simple object like a ball. Envision its perfect round shape, the smoothness in your hand. Imagine you must modify it to lay flat. Sounds unusual, right? Contemplate how you'd approach this. Could dissect the ball, turning it into fragments. It's like a jigsaw with these pieces spanning across a flat surface. Arrange them with care, avoiding damage. However, the result seems distorted. You observe these pieces and you see they appear twisted. You grasp the truth. The sphere cannot lie flat without appearing distorted. This puzzle is a reflection of a very real issue. Map makers have grappled with this for centuries. This is exactly the problem map makers face when trying to represent our spherical Earth on a flat map. This is where the Mercator projection comes into play. It's a map-making technique devised by Gerardus Mercator in 1569. Imagine wrapping a cylinder around the Earth, transforming the globe into a two-dimensional object, a concept akin to flattening an orange peel. Each point on Earth's surface is projected onto this cylinder, creating a comprehensive representation. Now what happens next? The cylinder is unrolled to give us a map, the Mercator map. This map is distinctive due to how it preserves angles and shapes, which is key for navigators plotting straight-line paths. However, this method results in distortions, magnifying areas farther from the equator, thus exaggerating the sizes of regions near the poles. Despite this distortion, the Mercator projection remains a vital tool in understanding our planet, its continents, and its oceans. Once this cylinder is unrolled, we obtain the Mercator map, a type of cylindrical projection that maintains angles and therefore shapes but distorts areas. For instance, if you have a 90-degree crossroad in reality, it will also appear as a 90-degree crossroad on the map. This accuracy isn't a coincidence, it's a deliberate design feature. Its purpose to provide an accurate depiction of our world. It's not just about land formations, but also the network of roads, highways, and intersections that cross our landscapes. Consider a bustling city intersection. The traffic lights, vehicles, and roads leading to various destinations form a 90-degree crossroad, a common feature in urban design. Now imagine that intersection on a map, replicated faithfully. But the accuracy extends beyond roads to sea routes. The trade paths and shipping lanes across the oceans are also precisely represented on the map. This meticulousness exemplifies the map's commitment to precision. This is a tradition dating back centuries, reflecting the skill of early cartographers. Their dedication is mirrored in today's maps, bridging past explorers and present navigators. This dedication to truth and representation makes these maps invaluable. They guide everyone, from adventurers to daily commuters. The very reason why maps still hold relevance in our digitally dominated age is because they offer a tangible connection to the world as we know it. Similarly, sea routes are accurately represented, which is why this map is still used in navigation today. However, the further we move towards the poles, the more distorted the sizes of countries become. This distortion is due to the Mercator map's design. It's a cylindrical projection, causing areas near the poles to appear disproportionately large. This illusion is because of the conversion of the 3D Earth into a flat 2D representation. Countries near the equator appear true in size, but those towards the poles seem exaggerated. This creates a skewed perception of the world. The further a country is from the equator, the more it's stretched and represented as larger than it is. These magnifications can be rebalanced to reveal the true proportions of polar countries. The discrepancy is most notable in high-latitude countries like Canada, Greenland, and Russia. If we transpose Russia, a large part of the northern hemisphere, to the equator, its size appears much smaller. The size difference is significant, illustrating how our understanding of geographical scale can be distorted by map projections. In conclusion, the Mercator map is not a deception or a conspiracy, but a geometric interpretation of our spherical world onto a flat surface. Introduced by Gerardus Mercator, this method has been a world map standard for centuries due to its use in sea navigation. It maintains angles, a key characteristic for seafarers charting sea routes, but it's not without flaws. The Mercator projection distorts the areas of countries, making them appear larger as we near the poles. For example, Greenland appears almost the same size as Africa, despite being 14 times smaller. A map is merely an abstraction of reality. It cannot encompass the Earth's surface complexities with total. It's not about one map being more accurate than another. Rather, they represent varying perspectives. They illustrate the cartographer's chosen priorities. Yet it's vital to understand the Mercator map's inherent distortions to avoid misinterpretation of countries' relative sizes. And remember this, the next time you look at a world map and marvel at the vast expanse of Russia, it's not as gigantic as it seems. It's all a matter of perspective and, of course, pure geometry. Now that we've understood the inherent distortions of the Mercator map, let's explore its effects more deeply. Consider Greenland. On a Mercator map, it looks as large as Africa. In reality, Africa is 14 times larger. This is the distortion effect of the Mercator projection, making areas near the poles seem oversized. Then there's Antarctica. It appears enormous, covering the map's bottom. Yet it's just about twice the size of Australia. Finally, Canada appears larger than the United States on the map, but the United States is about 3/4 the size of Canada. So, the Mercator map enlarges polar regions, making them seem bigger than they are. This happens because the projection tries to depict a 3D object on a 2D plane. Remember, no map is perfectly accurate, and each one presents its own unique perspective. That's all for today, folks. We hope you enjoyed our geometric journey through the world of maps. If you found this informative and want to learn more, don't forget to hit that subscribe button. Your support helps us create more content like this. We'd love to hear your thoughts on the Mercator projection and its distortions. Do you think it's still a useful map despite its inaccuracies? Share your thoughts in the comments section below, and hey, if you have friends who might be interested in this topic, feel free to share this video with them. Remember, knowledge is power, and sharing it with others only makes us stronger. Like or dislike this video based on your preference. Your feedback helps us improve and tailor our content to your needs. And last but certainly not least, click that notification bell. That way, you'll be the first to know when we drop a new video. Don't forget to turn on notifications so you never miss a new video from Knowledge Planet. Until next time, keep exploring.